Finally, we're ready to draw our stress block, and then we could do something like stress transformation, find the maximum stresses, whatever. So first thing, let's go back and look at all of the different stresses that we derived earlier, and we can start with normal stresses. And what we can see is that we're going to have our two normal stresses, and they come from P over A, and they come from M sub x C over I, both from acting in the negative y direction, so we have our equal and opposite, and when we add those two together, we get about 33 KSI. That's actually a little bit high, depending on the type of steel. If this were A36 steel, it actually yields at 36 KSI, and some of you may have even noticed if we had been looking at a different point, say 90 degrees around the circle from point A, the moment that was going around the the z-axis was actually a lot bigger than the moment about the x-axis. So we would be yielding this material, just like the bikes running into the garage. All right, so that's our normal stress, though, that is acting. Then we can look at our shear stress. To look at our shear stress, we want to pay attention to the fact that we had said it's acting on a face perpendicular to the y, and it's acting in the positive x direction. So the first arrow I drew was on the positive y face, pointing in the positive x. Then we'd have on the positive x, pointing the positive y, because we know that has to be there because tau yx equals tau xy. And then we'll just draw it on our opposite faces. It's our VQ over IT plus TC over J, and that ends up weighing 9.96 KSI as positive shear. Hope that worked out for you all on your answers.